This video is going to look at another example of calculating the upper and lower sums of a function. So here we have f of x equals the square root of x plus 2, and we are to find the area of the region below the curve on the interval from 0 to 2, and we want to use upper sums and lower sums with 8 rectangles. So we're going to go from the interval from 0 to 2. If we're using 8 rectangles, then the width is going to be the total length, which would be 2 minus 0 divided by the number of rectangles, 8, which is 2/8 or simply 1/4. So we could mark off from 0 to 2, we need to divide this into 1/4. So we would have 1/4, 2/4, 3/4, 4/4, which is 1, 5/4, 6/4, 7/4, and then 8/4, which would be 2. So if we're going to calculate the area, and if we look at the intervals here, our intervals, once again, you might want to actually list these out. So the intervals would be from 0 to 1/4, 1/4 to 2/4, 2/4 to 3/4, and from 3/4 to 4/4 are simply 1, and then 4/4 to 5/4, 5/4 to 6/4, 6/4 to 7/4, and 7/4 to 8/4, which would be 2. And let me see, 1, 2, 3, 4, 5, 6, 7, 8. So we have all 8 of our rectangles. And if I'm going to calculate the right endpoints, then if I'm using the right endpoints, that means I want to start with 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and 8/4. So that means if I start here, I'm going to start at 1/4. I would go up to the graph and then over, and that would give me my first rectangle. Now, if we do that, notice here, see if I can draw this a little bit better. If we go up and over, notice our point here, using our right endpoint, we are now looking at finding the upper sums for this example because our graph here, our rectangle rather, is going above the graph. So using the right endpoints for this example, the right endpoints are giving us the upper sum. And the notation for this, because we're using 8 rectangles, you may see a capital S and then parentheses 8, indicating the big S means upper sums and the 8 is the number of rectangles. So this upper sum is going to be equal to summing up all 8 of these rectangles. So if we're using the right endpoint, then at 2/4 we would simply go up and over, and then at 3/4 we would go up and over, at 1 up and over, 5/4, 6/4, 7/4, and at 8/4. And your graph doesn't have to be quite accurate, so you can see that mine isn't. And the key thing is you want to get a visual indicating here that we are looking at the upper sums, and that way you can also look at the idea that we are definitely using the right endpoint. So we're using the 1/4, 2/4, 3, 1, 5/4, 6/4, 7/4, and the 2. So we want to use these right endpoints. So again, we're going to leave off the 0 for this one. Now, if you want, you could go through and do the calculations like we did before. If we're going to calculate the area, then we know that the width is going to be 1/4 for each one. So we could factor out the 1/4, and then that's going to be multiplied by the length. Well, how can we identify the length? Here we have the width is 1/4, and the length then is going to be simply the height. Well, how do we start at 1/4? Well, we need to find f of, we could go through each one of these and I'm not going to list it again. You would need to find f of 1/4 plus f of 2/4, and then you would continue on until you get to f of 2, and then we could evaluate in the function. Just realize that now you need to plug f of 1/4, you need to plug the 1/4 into the square root. So the square root of 1/4 plus 2, and then you would take the square root of 2/4 plus 2, and so on. Add all of those values up and you could multiply by 1/4. Now, if we want to calculate the area using our summation, then we could take 1/4 out front, and we could start with I equals 1 to 8, because we're going to be summing this up starting at 1 to 8. We're looking at using 8 rectangles. And then we know that our function is going to be f of 1/4. Okay, that's your width. So 1/4 times I. So that'll give us each of our widths here as we increase. And let's see if that's going to give us our correct starting point. If we start with I equals 1, we get 1/4 times 1, which is 1/4. So therefore we start here at 1/4 on the right. If you plug in 2, you get 2/4. That's our next number, 2/4. And you plug in a 3, we get 3/4. And all the way up to 8, where you would get 8/4, which would be equal to 2. So this would be correct, except for now we just simply take our sum and we plug the 1/4 I. And again, a lot of times people forget this. You need to take this 1/4 I and substitute all of that in for x. So therefore, we're going to end up with the square root of 1/4 I plus 2. So we have the square root of 1/4 I plus 2. And again, this is the summation that we could enter into your calculator, just as I had shown you before. And if you do this calculation, you should end up with 6.03. And keep in mind, this is the upper sum, so you may see this capital S 8. And once again, this would be greater than the actual region. Now, can we do the same problem, but can we use this to calculate the left endpoints? Now, what happens if we use the left endpoints? Well, once again, we're going to mark off the same 1/4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and then 8/4. When we go to draw the rectangles now, we're going to use the left endpoints. And now we're going to be calculating the lower sum. And you can think of this as lowercase s8 for your lower sum. And if we start at 0, notice now we'll go up until we hit the graph, and then we'll go over to the 1/4 and down. And then we'll start at 1/4, we'll go up until we hit the graph, and then we'll go over and down. And then we'll continue the same process. We'll go from the 2 force, we would go up until we hit the graph, over and down. And notice now we certainly do have the lower sum because we have this part of the graph that we're not getting the area of. So we know that when we perform the calculations here, our number should be a little less than 6.03. So now we're going to look at calculating the left endpoint. So we're going to start with the 0, 1/4, 2/4, 3/4, 1, 5/4, 6/4, and stop at the 7/4. So calculating the area, once again, we know the width is going to be 1/4, and then the length would be f of 1/4 I. Now we know that if we do this, if we start with, forgot the summation here, we would have the sum of 1/4 I equals 1 to 8. We know that if we start with 1, that's going to give us the 1/4, but we don't want to start there. We want to start at 0. So just like we did before, to start at 0, then we would need to subtract away the 1/4. So if we double check this, if you plug 1 in for I, you get 1/4 minus 1/4, which means we would start here at 0. And if we plug 2 in, you're going to get 2/4 minus 1/4. 2/4 minus 1/4 is 1/4. And if you plug a 3, 3/4 minus 1/4 is 2/4. And if we go all the way up to 8, we would have 8/4 minus 1/4, which is 7/4. So we are starting at 0 and going all the way to 7/4. So here again, we're going to take and plug the 1/4 I minus 1/4 into our function. So we would end up with the area is 1/4 the sum of I equals 1 to 8. And if we plug this into the function we had, our function is the square root of x plus 2. So now we would have the square root of 1/4 I minus 1/4 plus 2. Okay, and don't forget the plus 2. A lot of times people start plugging this quantity in, the 1/4 I minus 1/4. You plug that in for x, and if there's other parts of the function, we forget about it. So don't forget to add the plus 2. So now all of this can be entered into the calculator, or again, if you prefer to do this by hand, you could go through all the steps up here and plug in the values into the function one by one. So if you prefer to do that, that is certainly fine. The calculator can quickly do this for you here, and just make sure once you enter this in, be careful with your parentheses. Make sure that you have, depending on your calculator, make sure that all of this 1/4 I minus 1/4 is underneath the square root and the plus 2 is on the outside. And make sure also when you finish the summation, or if you include it, make sure that you don't forget the 1/4 out front, so that when you calculate this problem, you should end up with 5.68. And this is going to be slightly less than the area of the region because, again, we find the lower sums. And again, you may see the notation where you have lowercase s parentheses 8 indicating the lower sum. Okay, and if you recall here with this example, the left endpoints was giving us the lower sums, and here the right endpoint was giving us the upper sum. And I believe in the previous video you saw an example where it was just the opposite. So keep in mind that what makes it upper and lower again is whether the rectangles are going above the graph or whether they're going below the graph. So hopefully now you feel comfortable with calculating your upper and lower sums. And keep in mind, you can certainly do these calculations here by evaluating each one of these by hand by plugging the 1/4, the 2/4, and so on into the function. Or if you prefer, you can set up the formula for the summation and enter that into your calculator as well.